ILCs, or innate lymphoid cells, are part of the innate half of our immune system, as the name suggests, and consist of NK cells and ILCs 1 through 3, which all have parallel T-cell adaptive immune system counterparts. Unlike other innate cells like macrophages, neutrophils, eosinophils, or basophils, most ILCs do not actively remove bodily invaders, but rather translate signals from other cells so that they may be acted upon. NK cells have a more specialized function and will be talked about in another video. For now, let's focus on the other 3 types of ILCs.
ILC1s are immune cells that defend against viruses and intracellular pathogens. They develop in the bone marrow and move to tissues like the gut, liver, lungs, and skin where they stay as local defenders. During infection, ILC1s release 2 cytokines, interferon gamma, which limits pathogen replication, expands ILC1s, and boosts macrophage and T-cell activity, and tumor necrosis factor alpha, which further activates ILC1s and triggers infected cells to self-destruct. Together, these cytokines drive type 1 immunity. After infection, ILC1s either die off or remain as long-lived tissue-resident cells.
ILC2s are the innate counterparts of type 2 helper T cells. Their primary roles are providing parasite defense and maintaining tissue homeostasis at mucosal surfaces like the skin, lungs, and gut. They're activated by epithelial cytokines, including thymic stromal lymphopoietin, interleukin 25, and 33. Once active, they release interleukin 5, which recruits and supports eosinophils, and interleukin 13, which drives allergic inflammation by inducing immunoglobulin E production, promoting fibrosis, and activating anti-inflammatory macrophages. They also produce amphiregulin, a growth factor that promotes epithelial cell growth and differentiation to repair damaged tissues.
ILC3s are the innate version of helper T cells called Th17. Their main job is to fight bacteria and fungi outside of cells and protect the gut lining. They mostly live at mucosal surfaces, especially in the intestines, where they keep the barrier strong and help control the balance of gut microbes. ILC3s are switched on by signals from other immune cells like IL-23 and IL-1 beta. They can also sense cues from food and gut microbes through a receptor called the aryl hydrocarbon receptor. Once active, ILC3s make IL-22, which tells gut lining cells to release antimicrobial proteins and repair any damage. They also make IL-17, which helps bring in neutrophils to fight infection. ILC3s also produce lymphotoxin to support the growth of lymphoid tissues and GM-CSF to guide dendritic cells and help the body tolerate friendly gut bacteria.
Hopefully now you know what ILCs can do with the body. They translate messages from one form of immune system to another in order to take out a large number of disease-causing microbes. Thank you for watching our video. See you next time.